Hello, everyone. It's right on 6:30, so we'll get started now. Welcome to CocoaHeads for September. We're back, another one in lockdown. Just a reminder, you can join the discussion on Slack. We've got the Slack link there, and I'll show it in a slide later. That's probably the best way to communicate throughout the night. But to begin with, I would like to acknowledge the Gadigal people of the Eora Nation, traditional custodians of this land, and pay my respects to elders, both past and present. A bit of housekeeping, intros as always. So, hey, I'm Zach. My name's on that slide. I help run CocoaHeads along with Nikki and Carl. Carl is also on the call. Hey, Carl.
Hi, everybody. Yeah,
as
that's all I've got.
That's right. I'll keep going. Yeah, anyway, hey, Carl. So a big thank you to sponsors as always this month to Bulu. And a reminder, as with any CocoaHeads event, CocoaHeads has a code of conduct, and we want everyone to feel welcome and comfortable at CocoaHeads. That applies to our online events, and that applies to when we're using the Slack community. So the full code of conduct can be read online, but it boils down to 3 key points. Be respectful, be inclusive, and be aware. If there's any questions or concerns, please speak to myself or Carl tonight. I will be around in the Slack. And on that note, another reminder that we do have the Slack community and is the best way to communicate both with the speakers and with other attendees throughout the night. We will also be holding a Zoom call after the talk, and the link to that will be posted in the Slack. So a big welcome to anyone who might be attending for the first time. Welcome. We hope you enjoy. And if you like what you see here tonight, we definitely recommend checking out Melbourne CocoaHeads. They run on the second Thursday of the month. So it's a week before us usually, but they have some really excellent talks, and yeah, definitely recommend checking them out if you like Sydney CocoaHeads. So things we shipped, a call out to things that people in the community have shipped over the last month. Matt Delves has shipped an update to ridestats with an iOS and macOS widget and display of electronic shifting data. So any cyclist should definitely check that out. I believe it has an iOS and a macOS app. So definitely worth a look. A little bit about tonight's schedule. We've had a last minute change. So unfortunately, Dan can't present his talk tonight due to technical difficulties, but we'll try and have Dan back in another month or so, maybe with a pre-recorded version or something to try and get that talk back. The second talk will be me doing a talk on SwiftUI and some gotchas there. And then following that, we'll have a Zoom catch up. So I'll post the link to Slack at the conclusion of the talk. As always, if people are looking for work or if people are hiring, the best place to promote that is in the jobs channel on the Slack. So feel free to head over there anytime throughout the month and post about the open position there. Or if you're looking for work, feel free to post there too. A couple of recent posts in that channel. UserCentric is hiring. Qantas is also hiring, and as is 3D Safety Systems. So in the Slack, if you have any questions about those roles, you can get in touch with the people who posted those jobs and hopefully find your next role. All right, so we're still looking for talks for next month. Realistically, it'll probably be online. So if anyone's interested in giving a talk, please let me know. Any lightning talks or month in reviews or anything like that are welcome too. But yeah, we'll probably have Dan next month, and ideally look for 1 or 2 more talks. So that's all I've got for the intro. This is where I was gonna pass off to Dan and give you all a break, but unfortunately that can't happen. So you're stuck with me for the next little while talking about SwiftUI 101 and some gotchas. This was a talk that I did for an internal meetup last week. And because the team that I'm on there, we've been using SwiftUI, and not all of the other teams have been using SwiftUI. So it was just kind of a good intro and general tips and advice for getting started with SwiftUI. So I'm going to go through, just a bunch of tips and stuff. So the first tip is you got to think different. I know everyone says it, and if you've worked with Swift UI, you'd know it, but declarative UI is just different. You kind of got to throw out a lot of what you've thought about UI design for however long you've been doing it. But the way to think about it is definitely you're telling the system what you want to happen, and the system goes away and decides how to display it. And that might be different on different platforms. For example, mystical AR glasses in the future might not have a background when you decide to display some text on the screen. But on your iOS app, it's pretty safe assumption you're going to default to having a background color if you've got some text on the screen. And this arguably means that pixel perfect design is dead. Not really going to get into that today because that's a whole other topic and a whole other debate. But yeah, it's definitely an interesting shift in the way we think about UI. So the next tip, modifier order matters. So if you look at any Swift UI code, you'll know that it's full of modifiers. And I've got a couple of examples here where we start with some text and we apply the same two modifiers, but we do it in a different order. So in the first example, the background is applied to a view that already has padding. And that results in the example you can see on the top there, where the background color is applied to everything that you can see. That includes the text and the padding. If we do that in the reverse order for the second example there, you see we apply a background to the text and then we apply padding to whatever that new view is. You'll note that the background doesn't extend out beyond the padding. Now, depending on the UI effect you're trying to achieve, this may or may not be what you want. But it is worth noting that the order in which you do things matters. And so if something doesn't work the first time, it's probably worth trying again with a different order. And the other thing to note with this is that some Apple APIs particularly only work when applied to certain views. So some of the modifiers only apply. For example, a button style, you need to actually apply that style to the button view itself, not to the content of that button. And that's one that I've been caught out with a few times where I am stuck thinking, why isn't this working? Only to be reminded that the order definitely does matter and the positioning of the modifier matters. So another tip for if you're just getting started, it's really easy to wrap UIKit and to fall in and out of Swift UI and UIKit depending on your needs. So it's definitely not we need to go all in with Swift UI. It's really simple to turn your Swift UI views into a UI view to call it from your UIKit code, or conversely to call your your Swift UI views from UIKit. You can see an example of that at the top. And the second example is using a UIKit view, like wrapping a UIKit view so that it can be used in a UIKit context. It is a bit more code, but you do get the hang of doing the wrapping dance after a while. The next tip is that stacks can be slow. We kind of know this from UIKit, where stack views are great, but if you have a lot of them, it can get expensive to render. It's unfortunately just as much the case in Swift UI. While there is a lot of optimization that's going on, if you do find yourself in a position where you have a lot of stacks, and like nested stacks especially, that can slow down performance. I'm not here to say don't use stacks at all. Their stacks are actually great, and probably in 99% of cases, you're not going to run into any problems. But I have seen performance issues with views that have stacks on stacks on stacks. And yeah, they're just slow to lay out. The best way around this is, particularly for a stack where all the items inside are the same width, you can use a geometry reader to measure the size you have and then just do like a simple division to calculate, say, the width or the height of each view. And that's way faster than relying on the layout system to lay it out. Again, for simple views, you're not going to notice the expensive computation, but for complex views, you definitely will. Had an example where kind of every update to a view was blocking the main thread for like a second and a half, and that wasn't great. And it was really easily fixed by wrapping it with a geometry reader. So yeah, the comment on the slide there is that it might be a bit premature to use this from the get-go, but if you do experience slow layout with stacks, at least you know potentially how to fix it. So rectangles to the rescue. I've got a really simple example here, and this is a very common way of creating a button. You might have, if we look at the code that's inside of the button there, we've got an H stack. So we've got our text label, which appears on the left, and we've got a spacer to, well, fill the space. And then we've got a check mark on the other side of the button, or that might be any other glyph that you put in your button. Weirdly, if you try to tap this button inside of that blank space there, the space that's only covered by the background, nothing will happen. Your action won't run. Bit unfortunate, but it is fixable. And the simple fix is to apply a content shape modifier to the actual content of the button. And this tells the system that it's tappable everywhere. It kind of turns it into a shape and fills out the available space. And that's really handy because, yeah, if you're just getting started and building some simple views, you might wonder why this isn't working. But there is a fix. And it's good. It's a good one. Another tip is really use previews and take advantage of them. It's very easy to forget about previews, but one of the things where I've found them most useful is in previewing a particular view with a whole bunch of variants of different traits. So this could be previewing both light and dark mode of a view, both light and dark combos, or it could be previewing it in a bunch of accessibility display sizes, or in the example here, content size categories. So you can quickly see your view as it would appear on a bunch of different sizes. And that's a really handy way to spot bugs. And it just kind of happens as you're working on the thing, it's updating its preview, and suddenly you get real-time feedback on whether your text fits inside the box and things like that. So you got to remember that preview, the previews property is just it's just any view. You can throw whatever you like in there. So you can do any amount of for eaching and grouping and apply modifiers and whatever to kind of create the perfect bunch of previews that you might want or need. So another tip is to animate values and not views, at least not views in their entirety. So it's quite common when you're looking at some example code for SwiftUI and you see a nice animation applied that you see the code on the bottom there. The really simple animation, you apply an animation style to a view. And what that will do is that any time a property that view depends on changes, SwiftUI will try to animate the changes. And this can look really nice, but in other times it can have unintended consequences. And it's also not really how you should be using the animation modifier. It's usually the case that when you want to apply an animation to a view, you want to animate a particular value changing. Maybe it's whether a button is pressed or not. Maybe it's some data that you're animating when it changes on the graph. But usually there's a property or two that you are interested in animating, and the rest you don't really care about. So and it's actually deprecated to use that second animation modifier as of iOS 15 and watchOS 8. So the recommendation is to use the first example where, along with an animation, you give it a value, and that value has to be equatable. And so the view will only try to animate the change when that equatable value is different. And this dramatically helps performance, particularly for complex views, because it's not trying to update on every state change. Your view is only trying to update when the specified property changes. And it's a really handy one. And that method that initializer for the animation has been around for a while, I believe since SwiftUI 1.0. It just wasn't very common to use until it was deprecated. But it's a cool little trick, and that's kind of why you should be using it. So just like most other parts of your code base, it makes sense to abstract things when they're either overly complex or going to be reused in a bunch of places. And SwiftUI's modifiers are no different. I definitely recommend abstracting either complex modifiers or ones just that you might use a lot out into their own custom modifier. And you can do that by extending view. And then you can apply that modifier to, well, any view. So in this case, you'll see that applying a border to a SwiftUI view is quite complex. You need an overlay and a rectangle inside of that, and you need to stroke the rectangle and apply some corner radius if you want to curve the border. It's a lot of code to write out each time, and honestly, I couldn't remember the exact order of those modifiers every time I wanted it. So I've created a custom modifier there, and you can see how it's used on the right, where you just simply apply a border, and that, to me, writing .border feels a lot more natural than having to apply an overlay. And like, if I looked at that overlay code, I wouldn't instinctively know that that's applying a border to a view. So yeah, anyway, that's a good it's a good thing to do. The other kind of useful place might be if you have a bunch of headers in a table view, for example, and you want to apply the same styling. Maybe you want them all bolded and a certain font. You could just abstract that logic into a custom modifier, and then to your text label, you could apply like .header text or something, and that's simpler than having to write out each of those modifiers in every place you want to use them. So good for design systems too. It's probably not strictly unique to SwiftUI, but it's good advice to reach for structs and not classes. This applies for everything really, but they're fast and cheap to initialize, and the SwiftUI view system really just kind of tries to piggyback off structs as much as possible. You notice that all SwiftUI views are structs, but it's good to keep your model objects as structs where you can as well. There's a few advantages, and not strictly necessary. Not strictly related to SwiftUI, but yeah, generally a bit lighter weight. No need to conform to NS object for certain things and whatever. Bit harder to cause a memory leak. If you try, you can, but yeah, it's kind of difficult. But the big one is that it really makes it easier for the system to reason about view refreshes, especially for structs that are equatable, because either the struct is different or it's not. When you have a view that's powered by a model that's a class, it's a little bit more tricky for the system to know when it needs to update that view or refresh it. And I am going to go into a lot more detail about that at the end of the talk, and just kind of the difference between the model types that you can use to power your SwiftUI views. Another good one, keep view initialization cheap. Ideally, you don't want to be doing any work in your views initializer. Data should either be calculated before it's used to populate a view, or before it's used to initialize a view, or it could happen asynchronously once a view is loaded. Like maybe the view shows and it's showing a loading state, and then that kicks off some processing on some data. But yeah, if your initializations are expensive, it's really going to slow things down. It blocks the main thread and your UI becomes unresponsive. And I've had that happen more times than I'd like to admit. So yeah, definitely something to look out for. But yeah. So another performance tip, you're probably sensing a bit of a theme here, is to break views out into smaller views. And you could really never do this too much. The thing to keep in mind is that when a view refreshes, it recomputes its body property. And every time a particular view refreshes, it needs to recalculate everything that's inside of its view property, I should say. And so the less that's in there, the less it has to do when it's refreshed frequently. And it's important to remember that SwiftUI views can refresh basically at any time and almost for any reason. Usually there's reason behind it. Usually it's because the data's changed or something and the environment's changed, but you kind of have to be prepared for views to be initialized cheaply and reloaded a lot. But yeah, they do only refresh when their dependencies change, but sometimes it's dependencies that you are not in control of. And that can be the environment. For example, the app switches from light to dark mode. Every SwiftUI view is invalidated and redrawn at that point because the app needs to redo itself. Redo its UI, I should say. So I've got a really simple example, and in reality, like this isn't going to make much of a difference, but you could imagine that if there was some complexity thrown on here, like the principles are the same. So in this view, I've got some local state. I've got the state and the state object, and I've got some external state, which is like data dependencies that are passed in from another view or external dependency somewhere. And anytime there's a change to any of these 4 properties, that entire body property will be redrawn. And what that means is you can see that there's 4 text objects and 2 buttons. Anytime any of them change, all 4 text objects will be re-rendered, and so will the buttons. Now, again, there's not much to this code. It's not very expensive. This could be refreshed all day, every day, and it wouldn't be a problem. But imagine that this was calling out to, say, more expensive, more complex views. And you kind of get where I'm going with this, especially when you consider that a Swift UI, an app for Swift UI is just view on view on view on view. You don't want to be refreshing everything constantly. So we can split this view into more views. We can split it into 3. So the view we started with is on the left there. And you can see that there were 2 clearly distinct sections. So there was the internal data that we're displaying and the external data that we're displaying. And by splitting them out, at first you might not think that much has changed. But what this means, when we go to calculate the body property on the first view, the view refreshes view, it will only refresh the body of internal view when one of those internal properties changes. And similarly, it will only refresh the body of external view if the value of the external counter or the external storage changes. And this is kind of a micro example of how to minimize view refreshes. So while that view refreshes view's body might be refreshing constantly, if the inputs don't change into internal view and external view, they're not actually going to be redrawn. For equatable dependencies, that's how it's diffed. For the class-based observed objects and whatnot, it's diffed a little bit differently, and I'll talk about that later on. But yeah, you kind of get the idea. So now when you hit the internal counter and increment that, it's only going to refresh that internal view. It's not going to refresh the external view because none of its inputs have changed. So yeah, it's important for a few reasons. But yeah, it really helps with the performance of the app. And like I said, if you've got kind of a central store that's constantly changing and constantly pushing data down throughout your app's views, it can get slow to re-render the views. And I have seen problems come of this. And one of the solutions is simply splitting out views more. So I've kind of already mentioned this, but a good tip is really only update the properties in your dependencies when you want the UI to update. And I'll talk a little bit later about how to control when certain changes to, say, your data model mean that the UI changes. But yeah, breaking your views down into smaller and smaller chunks it should be the goal. And really, a view is only going to be redrawn when its dependencies change. And some of those dependencies we have control over and some don't. So the ones we do should minimize their refreshes as much as we can. All right, so I'm on to the last section now. And this is all about understanding the property wrappers that we use. So the common ones you might see are state object, observed object, and bindings. So there's a lot of them. But I mentioned it earlier that they're the way we change or prompt a Swift UI view to refresh when one of its dependencies change. So I'll get started with state because that's the most simple. So state stores data that's local to a view. And because the views are constantly being, reinitialized, potentially torn down, reinitialized, we need something that persists the data between these view refreshes and these initializations. And so state should always be private. It's local data to a view. And when it changes, any dependent views are redrawn. It's used for simple structs, so things like ints, strings, and any other custom types you might have that are structs. You can annotate them with the state property, and when they change, your view will re-render. And binding is very similar, with the difference being that the view that declares a binding doesn't actually own that property. So you'll notice the state property, we set the initial value. Binding example view owns that button tap count property, but count button view relies on a count being passed in from an external view. So the initial value is kind of owned elsewhere. Also worth noting that we only need to bind a property if the view that it's being passed to is going to modify that property. So if not, if it's just a view to display that property, for example, this constant count display view, we can just declare it as a let property, and that view will be reinitialized when it changes. Very, very simple. We'd only need to make it a binding if in that display view we also had, say, an action that incremented the count for whatever reason. But in this case, we don't, so we can keep it as a let. It's quite nice. So state's hopefully quite simple to understand, but what about when we're dealing with objects? Well, how does a view know to update when its dependency is an object? And this is where observable object comes into it. So it's you can conform a class to observable object, and it provides a way for a SwiftUI view to understand when data has updated. So by conforming to observable object, you automatically get provided with an object will change publisher on the class, and any views that depend on an observable object will refresh when this object will change publisher is fired. And there are two ways to take advantage of this publisher and to call it. The first is using the published property. So you can see there the number of runs integer is a published property. And this is for, again, like struct back types. When they change, so in this case, number of runs, if I had some code somewhere that set it equal to 1 or 2, any views that depend on data model would know they need to refresh, because behind the scenes, the published property wrapper is firing that object will change publisher that I mentioned. The second way is to do it manually. So you can see there that in the will set of is running, I'm firing that publisher. Now, if I commented out that will set and didn't do anything, the fact that is running changes to true wouldn't be enough to prompt any views to do their refresh. So they both have their advantages. Published is really convenient, but I've also seen problems where, let's say you have 20 published properties inside of a data model and you're setting them all at slightly different times, like things, async things are happening and they might all be within half a second of each other, but it's going to prompt a lot of refreshes fast. And so the alternative there might be to wait until everything's set and then just do one call to object will change manually, and then all of your views refresh. So kind of two different tools you can choose to use, and they each have their advantages. So how do we use it? I won't go too deep into the weeds here, but just quickly, as I mentioned, the view will refresh whenever the object will change publisher on data model is called. So there are two ways to use an observable object, and the first is as a state object. And state object is very similar to state in that it's owned by the view that creates it, or at least it should be, and it persists between view refreshes. So in this example, results view might be redrawn a bunch of times, but there is only ever going to be one instance of that data model, and that's quite handy. The alternative, the other way, it's not an alternative, the other way to reference an observable object is to use the observed object property wrapper. And this is a bit more like binding in that it relies on a class that's kind of owned by another part of the system. So similarly, this view will refresh whenever a property of that data model changes, but you'd really only use observed object if that model was coming from either another view or somewhere else in your app that held a strong reference to it. And the reason is that observed object doesn't guarantee that the object will persist between view refreshes. It very likely will, but it's not guaranteed. And this was causing problems in some early versions of SwiftUI until state object became a thing. Because while it usually happened, it didn't always persist that object, and you might end up reinitializing that class over and over every time you view refreshes, and that's not great generally for performance, but can also have unintended consequences to your app if you think that this thing is living for the life of your app. So ideally, you'd only use the observed object when something else owns the data model that you're passing in. And that's just a nice summary slide of what I've just said, but I'm not going to go over it again. But if you're in doubt, you generally use state object. It's probably a good way to think about it. So another tip, responding to nested changes. If you have, say, an observable object nested within another observable object, it's not as simple as just adding the published property wrapper or adding another observable object property wrapper. It's not going to, the view isn't going to respond to changes to the nested model, unfortunately. And that's fine. We can fix this manually. So in this example here, you've got a parent model, which is owned by the view, and it has a child, which is also an observable object. And what that means is that the child has, the child has an objectable change publisher, and we can actually subscribe to this in the parent model to know when the view should refresh. So example code here, you can see in the init, I've added a subscription basically to the child's objectable change publisher. And so what this means is that anytime the child model updates, we will also prompt, we'll also call the objectable change publisher on the parent model. And that in turn will mean that the count view will refresh. That's just kind of how it has to be done. It does also mean that if, say, for example, the parent model only cared about one or two properties inside of the child model and they were published properties, we could subscribe to them and them only and not worry about getting view updates when other random properties change. But that's probably a bit outside the scope of this talk. And my last tip is keep state private. State should always be private. It really should have a one-to-one relationship with the view that creates it. And if it isn't private, you're probably misusing it. It's fine to pass it down through other views with bindings and whatnot. But if you're initializing a state object externally, it's probably not a great idea. And there's probably a better way to do what you want. So that's it for the talk. Thank you. We don't actually have another talk tonight, unfortunately. So CocoaHeads is almost over. I can see that there's a bunch of questions or a bunch of comments anyway, as the talk's gone in the Slack. So I will answer them in the Zoom call that we'll do post meetup. So as I mentioned at the top of the meetup, if you hang around, I'll post the link to Zoom and we'll have a Zoom catch up immediately after this. So thanks for joining, everyone. Hey, Carl. Carl's back.
Thank you, Zach.
Thanks, Carl. See everyone in the Zoom and have a good month. If you're not joining the Zoom, we'll see you next month. Bye.